Hello everyone, welcome. Thank you for joining me today for discovering some another way of testing. This is a new way that it's kind of giving us some benefits related to refactoring legacy code and also helping us to search for bugs that potentially our code bases could have. So I'm Sebastian Arias. I am a software developer for Stack Builders. I've been working here like 5 years, where I have gained experience working in different projects related to Python, TypeScript, and functional languages. So I have experimented functional programming paradigm since the beginning of my career. Just to mention, in my free time, I enjoy traveling, so I'm really glad to be here in Bogota to get to know the city. So, well, let's get started here. So, first of all, what is property testing? Property testing is a way of testing functions or our code bases, and not basing on our inputs and outputs, right? Like we normally do with other testing approaches. So what we are doing here is checking for high-level properties that our code has to comply and remain true through the time. Where it should be used. So it can help us to cover our code bases in a wide range of other checking other inputs that are not normally kind of easy to spot with inputs and outputs that we normally work with. So this has also helped us to detect and prevent some bugs with specific inputs that we might not taken into account before. So when we should use property testing itself. So when we start using and thinking in properties, we recommend to use these on complex algorithms or logic processes that our code is doing, right? Because we can cover everything just with the top of our mind ideas or inputs that we might want to check. So this helps us to generate a lot of inputs, and it helps to just gain confidence in our code base. And this was popularized with a library from Haskell language that is called QuickCheck. So how property testing differs from other testing methods? First of all, let's check the superpower input generation. What does this mean? Property testing generates inputs based on the strategies or the parameters that our functions have to call. So this is a different approach rather than creating manually inputs that we normally do, for example, in unit testing, right? When we just have some idea of what we have to do and then check it with an expected output. Property checking, the ultimate quality control. What does this mean? Since we have a huge amount of inputs that it's coming into our function, we can check that certain properties from our functionalities remain true through the time, instead of just checking specific tests with input and outputs. Bug discovery unleash the power of property testing. So normally, for when we got a bug, it's from another team or after our code has reached some sort of a stage when it starts to be tested, right? So someone raises their hand, says like, okay, we find a bug or something like that. So with property test, what we do is extend that coverage, since we do some inputs and outputs, some inputs that we just didn't thought of, and we start doing some other kind of tests that help us to gain confidence in our code. And finally, automated testing. So this is the speed of choice because we can run hundreds of inputs and tests that are kind of created by frameworks of property testing. Today we're going to be reviewing Hypothesis, a framework that is one of the most popular libraries in Python. So what is Hypothesis? Hypothesis is an open source testing library, and what it does, it provides developers the chance of implementing property testing on their functionalities, on their code bases. So basically it works by generating random input, checking how they can falsify these properties that they are doing by generating a counterexample. So once they found a counterexample, it's going to go to the smallest input that generates this, and raise their hand and say that the property is failing. So this in detail, what is happening here in detail. So what we do is, for all matching data and some specification. What does this mean? Since we are doing, generating some arbitrary but compliant inputs to our functions, we are checking to match and guarantee that our functionality is doing what it meant to do with the same input. What we do after we generate this information? We start performing some operations on the data. What does it mean? Just checking all the properties that our function must remain true through time. So what happens when hypothesis start doing this process? A hypothesis is doing generating this data and checking for the example that doesn't comply this specification. So this means that by finding this example, they know the strategy that they use to generate this data, and they start to shrinking or simplifying this generated output to the smallest input that causes the problem. And after that, they assert the result. This means that we are saving this result for the past to come, for the future interaction that we're going to do with the same functionality, but we don't forget that this specific input is failing. So this way we find bugs, and also we prevent this from happening again. So how to incorporate hypothesis in a project that we already have? So hypothesis works along with framework like unit test, that is the building module for Python unit testing, also with PyTest and nose. So how to get started with hypothesis itself? First of all, since this is an external module, we have to install a hypothesis in our project. We just can run a pip install as we normally do, or use a different package manager like Poetry if we are using that in the project. Afterwards, we're going to create a test file like we normally do when we start doing our testing in our code. And in this test, we're going to start writing test assertions or test functions. And we're going to start using in this specific scenario, hypothesis. What does it mean? That we are going to be grabbing these functions with hypothesis decorators to start sending this input generation data to our testing process. So how we specify the strategies that we are going to be sharing in given decorator is by passing these parameters to the function like we normally do when we start doing like mocks or other strategies to inject data. And finally, in this case, in the code that we're going to be seeing, we're going to be using PyTest. So if you don't already have it, you can install it as well. So let's go through some hypothesis basics to get us started with the code. So the first of all, the decorator that I mentioned earlier on is given. So what is given? Given basically is a decorator that specifies which arguments of the function are going to be parameterized into our test. This is important because hypothesis takes the functionality that is decorated by the given decorator as the entry point to make it a property test. So without this decorator, the test is not going to be treated as a property test. So this is why given is one of the core decorators that we need to know for property testing, using hypothesis at least. So now we jump to strategies. What is a strategy? This is how the data will be generated for the property test test. A hypothesis provides some functionalities for doing data types like integers, Boolean, strings, dictionaries, lists, and other sort of data types that we normally use. But if we have a specific scenario, we can customize these strategies to our own and to match our use case. So in this case, here is kind of the basic scenario of a property test in using hypothesis. So first of all, we're going to have to import the given and the strategies functionalities, and then we're going to have our test function, right? So in this test function, what we are going to do is generating some text data that is coming from the strategy text, that is the basic strategy from hypothesis, and passing it through the function as a parameter. So let's put hypothesis in action. So how we can use property test based testing and hypothesis to refactoring legacy code. So we are going to focus in this talk in three basic characteristics. Like, first of all, we're going to add our first property test for our existing legacy code. We're going to be working with a scenario of an encrypt and decrypt functionality. Then we're going to start creating some property tests and checking how we can improve it before refactoring it. Then we're going to put the property test in action. So we are going to check the test that we add into our code base, and let's see if they find out some scenarios that we might be missing from the test that we already have. And finally, we're going to start testing exceptions. As you know, handling exceptions or not checking the happy path of our code is kind of a core functionality that we have to start implementing. We just not need to test the happy path of stuff. We have to check if something goes wrong or something goes the wrong way. And this is a property as well in functionality. So let's start coding. First of all, I'm going to be sharing some code snippets where we're going to focus on these 8 characteristics in the code. First of all, we're going to review the legacy code of our functionality and the tests that they have, and start testing afterwards, adding our first property test. Then we're going to update some edge cases that we may find with our property test that we created. Then we're going to add some custom strategies just to check how we can interact with custom strategies that are not included in hypothesis, but we can create on our own, and then check how unit testing in this case how unit tests can cover this kind of edge scenarios that we found with property testing. Also, we're going to add custom strategies that not only return a basic input, we're going to be returning a tuple that it's going to include some information for our properties. Also, then we are going to check how we can prevent regression with property testing. And finally, we're going to complete the refactor and updates of our function in the code. So let's start coding. In this case, as you can see, here we have the first encryption functionality that we have. So, sure thing. Let me know if this is better. Perfect. Yeah. So, in this scenario, we have the encrypt function. As you can see, I'm using some well-known cryptography modules for testing, for implementing this function. And as you can see, it's really straightforward, right? We have 2 functionalities, the encrypt the string and decrypt the string. What does this mean? Encrypt is going to be kind of encrypting or adding this encryption to our string that is passing as a parameter, and the decrypt is going to receive an encrypted text and decrypt it. So in this case, since this is some legacy code that we've been assigned to update, we just check the test and we find out that we have these 2 tests, right? These are basic unit testing, that we have some sort of input that is a random string. And what we are doing is encrypt return bytes. Since you can see we have some type hintings here that saying that encrypt is going to return bytes. So we're checking that bytes is the type that we are returning, and also the test decrypt return original text. That is basically doing a round trip testing. That means we're encrypting something and then decrypting it, and the original text should be the output expected, as you can see here. So this is the basic testing that we have in this factory, in this legacy code. So we're going to test it right here, and as you can see, everything is going right. Yeah, both tests are passing, but I feel that this is not really good or have a great coverage of all the functionality or edge cases that we can have. So let's add our first property test to check what happens here. So now we have a new test, right? This is our first property test that we are going to be checking, and we have implemented as part of our knowledge in property testing. So as you can see, we're importing given and strategies, and we are using them to generate a new test. Our first test here is doing the same round trip example. So we are encrypting a text and also decrypting the text, and we should expect to have the same result. In this scenario, as you can see, I don't have like a sample string, since we are leveraging from property testing. In this strategy, we are generating the text input and passing it through our test like you can see here. So we are not in charge of generating the input. We don't have to kind of think of all the edge cases or possible inputs that our users can pass as a parameter in our functionality. So let's see what happens here when we run now the tests. So as you can see, we have our first error here. And it's saying also one of the characteristics of property testing is that they kind of show us what is failing in our test. In this case, as you can see, we have a Unicode encode error saying that ASCII is not a code that encodes characters of this type. So as you can see, maybe you spotted this earlier on in the code. We're just using ASCII encryption to work with our encryption string or encryption and decryption functionality. So this is an edge case that we just spotted that the previous owner of this code base didn't spot here in the unit test. As you can see, they did kind of basic testing. So here's one of the properties that property-based test give us here. So let's check some other examples right here. So let's address the code that we have, right? So now we are going to be handling this raise here an error saying that the input must be an ASCII string. So let's check if it does that the trick, right? So now if I run my test again, they are going to be passing. And as you can see, here we're adding a new strategy for our test that is kind of customized for our use case. Remember that previously we were just using strategies.txt to generate the inputs. In this scenario, what we are doing is a custom strategy, also with, some regular expressions that is generating non-ASCII characters. So we are passing this strategy, like non-ASCII regex, as a strategy to test our functionality. In this scenario, we are also testing an edge case, right? Every time that our code receives a non-ASCII character, it has to raise the exception, right? So we are doing here like with non-ASCII characters, our test, our functionality should always raise a value error that can match matches this input, right? We can do some other sort of assertions. This is the one that I used for the example. And as you can see here, we updated our previous test using some characteristics from the text strategy to just use ASCII letters. So in this case, we are doing the same, and we are adding an edge case that we, that actually hypothesis or property-based test spotted. So let's see, but we haven't done any refactor at all yet, but I still feel that we can just keep adding some other properties just to make sure that everything works. So in this scenario, what we are doing is kind of generating a new strategy for the ASCII text. In this case, what we are doing is adding a new test for our decrypt function, right? Previously, we were just focusing on the encrypt. So what we are doing here is something similar that we have in a previous test. That is that the original text should be matching the decrypted text from an encrypted text. In this case, I am creating another custom strategy, but in this case, I am kind of customizing it at the point that I'm, instead of returning just an input or a basic input like a data type, like a string or an integer or something, I am returning a tuple with the original text, as you can see here, and also the encrypted text. Why this is happening? Because since this is kind of generating automatically a lot of input data that is generated from these strategies, I cannot rely on something that is kind of similar like we have it here, right? Since we are testing just one scenario in this case. In property testing, as we are testing a property, the data is being generated automatically, and we have to kind of customize these strategies in this type of scenarios. So we can check that the test is kind of similar, but as you can see, I am passing this encrypted text strategy, that is the custom one that we just built, for asserting this type of properties. So if we run this again, this is working. As you can see, everything is green. We are conserving it, but still not doing some refactor here. So let's focus right now that we have our test in place, let's focus on some refactor. So let me see, in this scenario, what do we have here? Okay, in this scenario, before doing our refactor, we're checking the unit test encryption test that we have previously on. I have also updated them a little bit to double check that what we have to think on ourselves to cover the properties that our test already implemented, right? So as you can see, this is kind of straightforward. We are just doing some setup. In the other test, you see that we don't have to do this kind of scaffolding for testing. Also, we are doing the same encryption in this regard. So we are asserting the same round trip properties here, but here comes the interesting thing. In the previous tests, we didn't assert on errors, right? So thanks to property testing, we just spotted that we have everything under control, and also we leveraged our exceptions, right? And then this is kind of some scenario that none of us might have think, right? Testing without non-ASCII characters, unless we just spotted that from somewhere else or someone raises the hand on that regard. So this is kind of the way that our unit test should have to kind of look up a little bit in terms of this. So let's see the final kind of refactors that we have. In this case, the encrypted functionality has been moved to a module, right? Where we have some abstractions in terms of setting up encryption keys, some ciphers that are the client. We're doing some better practices in this end. And as you can see, if I write my test, this is still compliant, right? Because we're testing a high-level property instead of testing specific scenarios. But let's say that for some business-related stuff, we just have to do some update and stop using this library, and we are using a new type of encryption because of some security issue that we might have encountered. So let's check. I've created kind of the encryption update, right? So in this case, as you can see, I'm using another set of tools for encryption, and we have to do some updates, right? But the structure of our module remains the same because of the previous refactor we have. So also I added some property tests that are basically the same ones that we have, but in this case, we can do some sort of check if we don't have regressions, right? So as you can see, here we have a failure that is kind of the assert that our code, our property test is saved to double check in case that we miss it again. So this way we prevent regression that we might have missed while doing our updates. So basically what we have to do is implement the same solution, and as we can see here, I implemented here in the encryption update this same kind of exception handling, and if we write our test, everything should be green right now. So this is basically how property tests help us to manage some edge scenarios. So let's see how some advantages of using hypothesis. So in brief coverage, we cover a huge wide range of inputs instead of handmade inputs that we might be thought or think about our code. We discover edge case scenarios. As you can see, without doing some hard debugging or something, the properties, the input generated did some great job at finding edge cases. Also, we have efficient debugging because we have a specific scenario where our code is failing, so we don't have to spend time on kind of replicating these edge cases. And also the code refactoring was really straightforward because if you can see, we have some basic functionality and then we refactor it to a module, and we could also do some extra refactoring using new libraries, but we still apply to the high level functionalities instead to specific cases. So those were the advantages of hypothesis. Now let's focus on property testing advantages itself. So we cover edge cases. So we define properties that should remain true for all scenarios, and we generate diverse type of inputs that help us uncover unexpected behavior, like the one that we just spotted about the ASCII encoding. We can integrate this to pipelines, like continuous integration and continuous delivery straight away. This is really fast, so we don't have to do some extra work on that regard. Also, we test property-based assertions instead of input-output scenarios. We do a high-level kind of thinking of our our functionality, not how it should work. So we have randomized input generation. So the inputs are based on the strategies, not on what we could have thought. And also we can explore more range of inputs, right, instead of specific scenarios. So also, we can simplify test cases. As you can see in the other way of testing, we have to do a lot of things like some scaffolding, prepare the inputs, the outputs, and have that ready. In this scenario, we just focus on the properties, and that's all. Some potential pitfalls that we can have with this type of testing. So data generating issues. In our example, we just have a basic scenario of the input that we have and the output that we're expecting. So let's say I have tried to do this type of testing with more complicated scenarios like, I don't know, validating JSON schemas and stuff like that. The data complexity grows. So we have to be careful on that to prevent a false positive or unnecessary complexity in this regard. Also, some assertion errors. So we can have a false positive and miss important edge cases because we might not be thinking on the right property, or the data generation is that complex that is not able to find this kind of edge cases. So what's next for the property testing journey, if you've just find out of this approach? First of all, I encourage you to review the hypothesis docs. They have a huge functionality that help us in different edge cases, different scenarios that we might encounter on our daily basis, and help us cover and extend this wide range of cases in our code. Then start thinking in properties, not just input and output scenarios. So it's easier to think for us as developers that maybe we do a unit testing or some sort of techniques like unit testing, that we think of the input and we think of the expected output, but not of the property that the functionality should hold, right? So start thinking on that high level property instead of input outputs. Last, this is kind of a suggestion for you. On Sunday, we have a workshop related to property testing where you can put your hands on some coding. So I really encourage you to assist and save your spot on that workshop. So this is a space for you guys. I don't know if any of you has questions, some doubts or suggestions. Yep.